Imitation modeling of the subsystem of identification and structure of surface acoustic wave sensor signal data. Micro and nanotechnologies are the priority fields in science and technology in present-day Russia. They allow to realize and implement complex technical objects of minimal physical size. However, current state of development in these spheres shows a number of problems connected not only with the design of such objects, but with their implementation as well. It should be noted that the major importance in this situation is attributed to the detailed analysis of physical properties of both new alloys and the separate elements of micro-objects that acquire new physical properties with the changes in their geometry. The developed imitation model of the subsystem of identification and structure of surface acoustic wave sensor signal data will contain the set of data of the physical process corresponding to the changes of physical properties of the studied object. Surface acoustic waves are elastic vibrations of subsurface layer of the material. The form and type of surface acoustic waves propagation reflects the ongoing physical process in a physical object. That means then when identifying and analyzing the surface acoustic waves, one must consider not only the structure of the signal, but the physical parameters of the object of study, material chemical compositions, as well as the possibility of the impact of external factors. It should be also noted that the analysis of most common types of SWAS has shown that the information on ongoing physical process is focused in the shift of the sagittal plane. To model the subsystem of identification and structure of data from surface acoustic wave sensors, one needs to develop the algorithms describing the procedure of registering surface acoustic wave sensors, as well as the characteristics of accumulating and structuring data on surface acoustic waves. In analyzing surface acoustic waves, the special significance is given to digital signal processing. It's worthwhile to use a wavelet transform for this analysis. As a result of wavelet transform, we obtain time and frequency range of the registered signal. Using the parameters of the obtained time and frequency signal range, one must determine the class of that signal as well to the single out of the signal data components. Collecting data on surface acoustic waves should be done continuously. On the basis of the data obtained earlier, the database is built and the information structured with the aim of conducting further detailed analysis and more precise identification. The slide shows the sequence diagram that represents the process of accumulating signals and building the identification models for recognition of different classes of signals. And the imitation experiment was conducted in MATLAB using the results of the system analysis of source and the characteristics of identification and structure of data received with the help of UML models. The data provided by imitation model allow to determine the surface acoustic waves' velocity change and their attenuation, building the graphs of changes in the velocity of compressional and transverse waves, finding functional and correlation dependencies, physical and mechanical surface characteristics. The results of modeling allow to make a conclusion that structure of source sensor data and creating the database of reference source signals as an important problem now. The theoretical and practical interest in studying the surface acoustic waves is determined by the need to analyze and structure the information on ongoing physical process in physical objects. The developed models allow to create database of recognition models and reference models, which in its turn will allow to increase the precision of signal recognition and provide insight into ongoing physical process in the physical objects. Thank you for your attention.